Welcome to Unit 9, Lesson 3, where we'll learn how to use the zero product property to solve a quadratic. Unit 9 has been focused on graphing quadratics, and in Unit 10 we're going to start solving them. But in order to do our next graphing method, we need to learn a little bit about how to solve a quadratic. The easiest way to solve a quadratic is if it's already in factored form and you can use the zero product property. So that's what we're going to learn in this lesson. So the zero product property, or ZPP as I like to call it, says that if you take the product of two numbers and get back 0, then one or both of those numbers must be 0. So product means multiplication. So what this is saying is if I multiply two numbers, A and B, and the answer comes back 0, then one of those numbers must be 0. There's no way to multiply two numbers together and get back 0 if one of them wasn't 0. So this may seem like a so what property, who cares? But it actually is really going to help us for solving a quadratic. Currently, we don't know how to solve a problem like x squared plus 5x plus 4 equals 0. But something you're going to learn in the next unit is that you could rewrite this into what's called a factored form. You don't realize this yet, but this expression and this expression are actually the same expression written in two different ways. This second way is called factored form, and now shows one quantity multiplied by another quantity equaling 0, which starts to sound a lot like the zero product property and turns into a problem that we can actually solve. So let's take a look at some problems that start off in this factored form and learn how we can use the zero product property to solve them. What ZPP would say about this problem is that if these two expressions multiply together to equal 0, then one or the other must equal 0. So when there's a variable involved, what we're going to do is we're going to take this first expression and find out when it equals 0 by setting it equal to 0 and solving. If I subtract 1 from both sides, I get x equals -1, and that's actually going to be one of our solutions. Because if I plugged -1 in, I'd get -1 plus 1, which equals 0, and then it wouldn't matter what this expression is because anything times 0 equals 0, so it'd be a true statement. So x equals -1 is one of our solutions. Next, I'll set the other expression equal to 0. And then I'll add 2 to start solving for when would this equal 0, and it would equal 0 when x equals 2. And just like we said for -1, if we plugged it back into this half of the problem, we'd get 2 minus 2, which equals 0. So this expression would equal 0, and it wouldn't matter what's going on over here because anything times 0 equals 0. So 2 would work as another solution. So that means for this problem we have two solutions, x equals -1 and x equals 2. So to summarize the strategy for solving a problem like this, you just take the two things that are being multiplied together to equal 0, you set each one equal to 0, and solve. What this does is it turns one messy expression into two pretty easy equations to solve. And that problem would be done. Now there's less parentheses in this next problem, but it's still a multiplication problem. For the zero product property to work, we need this whole expression equal to 0. Now we're going to be nice to you in this lesson and always have it equal to 0, but that's not always true. This property only works when it equals 0. So we have two polynomials here, a monomial 4x on the outside and a binomial 3x minus 6 inside the parentheses. We're being told that this first monomial times this binomial equals 0. That means we can use the zero product property. I'm going to take this 4x and set it equal to 0. I'll divide both sides by 4, and we get x equals 0 as our first solution. And then I'm going to take this second polynomial, 3x minus 6, and we're going to set that equal to 0. I'll add 6 to get 3x equals 6 and divide by 3 to get a final answer of x equals 2. And again, the idea here is if I took this 0 and plugged it in, it'd make the outside 0, and then it wouldn't matter what was in the other expression because 0 times anything equals 0, so 0 would work as a solution. It would make a true statement. Same thing with this too. If I plugged it in, it would make this polynomial 0, and then it wouldn't matter what was going on over here because anything times 0 equals 0. Same thing going on for this problem. We're going to take this x minus 5 and set it equal to 0, and this 2x minus 1 and set it equal to 0. I add 5 to both sides on that first equation to get x equals 5. And then on the second equation, I'm going to add 1 and divide by 2. I get a fraction answer this time, which we could also turn into a decimal, 0.5. and that's okay. We don't have to get whole number answers. And this problem would be done with the two solutions of x equals 5 and x equals 1/2. Finally, one more problem that's a little bit special here. Let's start off by doing what we've been doing. You take the first monomial this time, 3x to the fourth equals 0, and set that equal to 0. And then we take this x plus 9 and set that equal to 0. That second equation is going to be pretty easy to solve. Subtract 9 from both sides, x equals -9. This equation might be confusing because we're not used to seeing something like a fourth power. Now there's a trick here that we're going to be able to rely on later on that just says anytime you have a monomial equal to 0, that gives you a solution of x equals 0. So I can already tell you that the answer to this half of the equation is going to be x equals 0. Now if you really want to know why, we could divide by 3 and get x to the fourth equals 0 and do something called fourth rooting both sides, and the fourth root of 0 equals 0. That's one way to do it. The other thought is just this. 3 times what is going to equal 0? Well, that's actually zero product property again. It'd have to be 3 times 0. So we know this x fourth has to equal 0, which again we could have done by dividing both sides by 3. But then we need to think, what times itself 4 times could equal 0? Well, the only way for a multiplication problem to end in 0 is if something in that multiplication problem equals 0. It's kind of what the ZPP says. So really the only way to get this would be raising 0 to the fourth power, and that's why x equals 0. Again, the trick here is anytime you have a monomial on the outside, it's going to produce a solution of x equals 0. There's no other way for this constant to be multiplied by anything else to get back 0, so the variable must be 0. And then these would be our two solutions, x equals 0 and x equals -9. So there we have 4 problems that explain to us how the zero product property works. To summarize, in order to use the zero product property, the quadratic must be in factored form. Once it's in factored form, all you need to do is set each factor equal to 0 and solve. If you came away with anything else, write that down now. Otherwise, we'll see you in the next lesson.